All right, so let's start talking about ionic bonds. Remember here we're talking about a transfer of electrons. And then we're talking about metal plus nonmetal. And remember, metals are easy to lose electrons. Nonmetals are hard to lose electrons. So the electron is going to go from the metal into the non-metal, right? Metals give up their electrons easily, so they're going to be the ones that are donating the electrons. And so with our Lewis dot structures, we can predict the stoichiometry of products. And so this is probably something you could do from previous in this class, but now we're kind of explaining the why, right? So if we think about potassium has 1 valence electron, and then if we add this to chlorine, it has 7 valence electrons. And so to think about both of them having a filled valence shell is this electron needs to go there. And then what you'd end up with is a K plus that would still have a filled valence shell, just the one below it. And then a chloride. So a chlorine with 8 valence electrons, you can tell has a filled valence shell and a negative charge. So the overall formula here is KCl. So you can see the predictive power, probably something you could have done before this because based on the charge stuff that we learned in the beginning of class. Let's take a look at between sodium and sulfur. So sulfur has 6 valence electrons, sodium has 1. And so you can tell this one needs 2 electrons to have a filled octet. This sodium can only donate 1 electron. So what are we going to do to even things out? Well, we're just going to have 2 sodiums. And then both of these electrons can go into the sulfur to form a sulfide. And thus your stoichiometry would end up being 2 sodium positives and a sulfide, 2 minus, right? Or Na2S, as we previously learned. So you can predict the stoichiometry. It's really not too bad. Just one more final example, sodium and chloride. Did we not do that one already? Oh, we did potassium and chloride, I see. So 7 valence electrons, 1 valence electron. This electron is going to hop right into there, and you'll form Na plus and then a chloride. Cl minus, and so it's NaCl. So sometimes you'll see a pictorial representation of this, right? So you have your Na plus as this thing, and then you have your Cl minus as another sphere, and then there's your ionic bond, right? Because the positive and negative are attracted to one another. And so this is we'll call this a pictorial representation. But this isn't actually kind of what an ionic bond really is. So it's technically not correct. And to think about that, you have to think about what's really going on here. And it's not that we just have 1 sodium and 1 chloride. We have a whole bunch of them. And so they organize each other into what's known as a lattice. So we have a bunch of positive charges, those are the sodiums, and then a bunch of negative charges surrounded by the chlorine. And so one thing you kind of want to realize is that each one of these ions are actually bonded to all of the neighbor. So the ionic bond isn't just between 1 sodium and 1 chloride. It's between 1 sodium and maybe like 8 chlorides. So ionically bonded to all the neighbors. Cool.